In this question, we have 4 people who are going to compete in a relay team. It's basically a marathon where we've got 4 different events. We've got a swim, a run, a canoe leg, and a bike ride. And in this matrix, you can see the time that each person can achieve. That's their best time. And what we want to do is pick a team where each person only competes in one aspect of the marathon, and we want to get the team to achieve the best possible time. We can use the Hungarian algorithm to help us do this. And in this example, we're going to go through this algorithm in a very simplistic manner. So we're going to go through the steps rather than explain why these steps work. We're just going to go through the process of actually showing them. So in the first case, we look at each row and we select the smallest entry in that row and subtract it from each entry in the row. So in the first row, we're subtracting 90 from each entry. And these are, of course, times in minutes. In the second row, the smallest number is 105. So we subtract 105 from each entry. In the third row, the smallest number is 85. Again, we subtract 85 from each entry in the third row. In the last row, the smallest number is 135. Same again, we do the subtraction of 135 from each entry in that row. So that's step 1 done. Step 2 is to look at each column. And the same process applies. We're going to select the smallest entry from each column and subtract that number from each entry in the column. So if we look at column 1, the smallest entry is 65. That does occur twice, but the same process applies. So 120 minus 65 is 55, etc. In the second column, the smallest entry is 0, so we subtract 0 from each entry, and of course the same occurs. Smallest entry is 5 in column 3, and we subtract that from each entry in that column. And the smallest entry in the last column is 35. The next step in this process is to cross out the zeros, but we try to do that using the minimum number of horizontal and vertical lines. So in this case, what we can see is that we do have column 2 with lots of zeros, so we'll cross that one out first. We've got a few more choices now, but we'll notice that row 4's got a couple of zeros, so we'll cross that out. Now we've got some choices between row 2 or column 1. We'll cross out column 1. We've only got 1 0 left, that's in column 4. So we examine the number of lines that we've used. In this case, we've used 4 lines. Now because that matches the size of the matrix, in other words, it's a 4 by 4 matrix, we can stop at this point as far as crossing lines is concerned, and we can now look to allocate our solution. We must find a 0 that exists in each row and in each column. Row 1 only has 1 0, so there's no choice, we have to allocate that. Now we'll look at row 3. There are 2 possible zeros. The 0 in column 2 has already been used up. In other words, there's a 0 in column 2. We have to go for the 0 in column 1. Now in row 2, there are 3 zeros, but the zeros in column 1 and 2 have been used up. We have to go with the 0 in column 4. And the last row, there's no choice. We have to go to the 0 in column 3. And they match our solution. So to minimize the time, what we then do is we match these zeros back to the original matrix. 150 is the 0 in the third row. In the second column, the top entry is 90. 140 matches the 0 in the last row of our matrix. And the 0 that we get in the last column matches 140. So this is the best time we can achieve with our 4 athletes. And if we add these times up, we get a total time of 520 minutes.